going to do question 13C. This question involves a combination of resistant motion and projectile motion. In such problems, resolving forces, velocities and accelerations along both vertical and horizontal directions is crucial for understanding the motion. So therefore, before I start my question, I will explain you some key points to keep in mind. First thing is vertical and horizontal components. So the motion can be analyzed by splitting the forces and velocities into their vertical and horizontal components. So if we are talking about vertical motion, the velocity in the vertical direction decreases as the object rises due to gravitational deceleration. So at the maximum height, the vertical component of the velocity becomes zero. Beyond the maximum height, the object accelerates downward due to gravity, increasing its vertical velocity. Then if you are talking about the horizontal motion, in ideal projectile motion, if there is no air resistance, the horizontal velocity remains constant because no horizontal forces act on the object. However, if resistance such as air resistance is considered, the horizontal velocity decreases over time due to the opposing force. Then what about the resistant motion? Resistant motion in real world scenarios, resistance like air drag plays a significant role in both the vertical and horizontal motion. The resistant force is usually proportional to the velocity and acts opposite the direction of motion, which complicates the equation governing the object's trajectory. The deceleration due to resistance affects the object's range, maximum height and the time of flight. Okay, now let's talk about the maximum height. Now, at the peak of the object's flight, the vertical velocity is zero, but the horizontal velocity may still be non-zero depending on whether air resistance is considered. The maximum height can be found by using kinematic equation or energy conservation principles. Landing. The object reaches the ground when its height is zero. At this point, the vertical displacement becomes zero, and the total time of flight can be determined using equation of motion. The horizontal displacement at the point of landing gives the range of the projectile. Okay, now I'm going to do question 13C, that is a particle of mass 1 kilogram is projected from the origin with speed 40 meter per second at an angle 30 degrees to the horizontal plane. So if I draw the diagram, it is something like this. This is X, this is Y. So then it is 40 meter per second to 30 degrees. This angle is 30 degrees. That one is 40 meter per second. Now I can write this velocity that is equal, initial velocity is 40 cos 30, that is along the horizontal direction, that is I, plus 40 vertical direction 40 sine 30 j. So therefore, if I simplify that one, 40 times cos 30 is root 3 square root of 3 divided by 2I plus sine 30 is 40 times half j. So therefore this one is equal 20 square root of 3I plus 20j. So therefore I can write V is V initial velocity V0 is equal horizontal component is square root 20 square root of 3, vertical component is 20. Now let's go to 13C part 2, that is the forces acting on the particle are gravity and air resistance. The air resistance is proportional to the velocity vector with a constant of proportionality 4. Let the acceleration due to gravity be 10 meter per square second. So the position vector of the particle at time t seconds after the particle is projected is rt and the velocity vector is vt. We have to show that velocity vector is that one. Okay, so now so what I want to prove that velocity vector is this one. Now for this one I'm going to the vertical and horizontal components, so that is of forces. Then along the vertical direction, if I use F is equal to ma, then along the vertical direction we know that force is equal to minus mg because due to the gravity, and minus 4 y dot, because the velocity along the vertical direction is y dot, the air resistance is 4 times y dot. This force is equal to m times the acceleration along the vertical direction is y double dot. Now we know that m is equal 1, therefore I can write y double dot is equal minus g minus 4y dot. So which mean y double dot is I can write d y dot divided by dt is equal minus g minus 4y dot. I can do some rearrangement, then that is dy dot divided by minus g minus 4y dot is equal dt. Now I'm going to integrate both sides. So this one is equal dy dot divided by g plus 4y dot. I multiply both sides by minus. So this one dt. So that is minus dt. Okay, so now when I integrate this one, this side is equal to 1 over 4 ln g plus 4y dot, that is equal minus t plus c. So then ln g plus 4y dot is equal minus 4t plus c, because if you multiply the constant by 4 it is still a constant. Then this one I can write as g plus 4y dot is equal e to the power minus 4t plus c. So now that 40 minus c, I can write g plus 4y dot is equal e to the power minus 40 times e to the power c. E to the power c is a constant. I will write this as a. Then we have to use the initial velocity to find the constant a. So we know that initial velocity is at t is equal 0. Initial velocity was y dot was equal to 20, and we know that g is equal to 10 meter per square second. So if we substitute this value, this is equal 4 plus 4 times 20 is equal a times e to the power 0. So therefore a is equal to 90. Now I can write this one, therefore 10 plus 4y dot is equal a is 90, therefore 90 e to the power minus 4t. Therefore if I simplify, y dot is equal to 90 divided by 4 e to the power minus 40 minus 10 over 4. So which is equal 45 divided by 2 e to the power minus 40 minus 5 over 2. Okay, this is the velocity at any time t. Now vertical velocity. Now we want to find the horizontal velocity, therefore I will use the f is equal ma to the horizontal direction. So this is equal mx dot is equal minus 4x dot, because air resistance is proportional to velocity, and the constant is minus 4. Now m is equal 1, therefore I can write this one is x dot x dot is equal minus 4 x dot. Now x dot mean dx dot divided by dt is equal minus 4 x dot. Then I can write dx dot divided by x dot is equal minus 4 dt. Now I'm going to integrate both sides. Then dx dot divided by x dot is equal ln x dot is equal minus 40 plus c, which is equal x dot is equal e to the power minus 40 plus e to the power c I can write as b. So therefore x dot is equal b e to the power minus 40. Now initial velocity along the horizontal direction is when t is equal 0, x dot was 20 square root of 3. Then I can substitute these values into that one to find the constant b. X dot is 20 square root of 3 is equal b e to the power 0. So therefore b is equal 20 square root of 3. Now if I substitute this value, we can find x dot is equal 20 square root of 3 e to the power minus 40. So therefore vector is velocity vector v t is equal, horizontal is 20 square root of 30 e to the power minus 4 t, vertical velocity 45 divided by 2 e to the power minus 40 plus minus 5 over 2. Okay, now let's go to question number 13c part 3. So that is, we have already know that velocity vector v t is equal 20 square root of 3 e to the power minus 4t, 45 divided by t e to the power minus 4t minus 5 by 2. So we found this one. So now what we need to find the displacement vector, that is rt, which is this one. Okay, to find that one, let's start with the velocity. Now we know that along the horizontal direction, velocity is dx divided by dt, that is equal to velocity is 20 square root of 3 e to the power minus 40. So then I can write this as dx is equal 20 square root of 3 e to the power minus 40 dt. Now if I integrate both sides, then I can say x is equal 20 square root of 3 minus 1 over 4 e to the power minus 4t plus c. Minus 4t plus c. So this is equal x equal 5 square root of 3 e to the power minus 4t plus c minus okay. Now when t is equal 0, at initial stage x is equal 0, we start from the origin. So then I can say that 0 is equal minus 5 square root of 3 e to the power 0 plus c. Therefore c is equal 5 square root of 3. Now if I substitute that c into the x equal minus 5 square root of 3 minus 5 square root of 3 e to the power minus 4t plus 5 square root of 3. So therefore this one I can simplify, x equal 5 square root of 3, I can take outside 1 minus e to the power minus 40. Okay, this is along the x direction. Then along the y direction, this way dy over dt is equal dy over dt, we have found that it is equal y dot, that is dy over dt is equal 45 divided by 2 e to the power minus 4t minus 5 over 2. So therefore dy is equal 45 divided by 2 e to the power minus 4t minus 5 over 2 dt. Now I am going to integrate the both sides. then this side is equal y is equal minus 5 over 2 t minus 45 divided by 8 e to the power minus 4t plus c, because it minus 40 you divided by minus 4, then it will become minus 45 divided by 8. So then to find the c, initial condition is when t is equal 0, y is equal 0, then I can say that y is equal this one is 0 minus 45 divided by 8 e to the power 0 plus c, y is equal 0. Therefore, c is equal minus 45 divided by 8 plus. Okay, so therefore I can write y is equal minus 5 divided by 2 t minus 45 divided by 8 e to the power minus 4t plus 45 divided by 8. So this is equal minus 45 divided by 8 I can take outside. This is equal e to the power minus 40t minus 1 minus 5 over 2 t. So therefore this is equal y is equal minus 45 divided by 8. I can multiply by negative, then this one is become positive. So this is equal 1 minus e to the power minus 4t minus 5 divided by t. So therefore the displacement vector I can write rt is equal 5 square root of 3 5 square root of 3 1 minus e to the power minus 4t 45 divided by 8 1 minus e to the power minus 4t minus 5 over 2 t. Okay, now let's go to 13C part 4. Now what you have to do, using this diagram on the whiteboard, find the horizontal range of the particle, giving you answer rounded to 1 decimal place. Okay, when you are talking about the horizontal range, which mean the particle is now on the ground, so that mean vertical displacement is 0. Now we have found that the vertical displacement is rt y at any t, that is equal 45 divided by 8 1 minus e to the power minus 4t minus 5 over 2t. So this is the vertical displacement. Now when the particle land on the ground, yt is equal to 0. So that means 45 divided by 8 1 minus e to the power minus 4t minus equal 5 over 2t. So this one we can divide it 45 by 8 both sides. So that is 1 minus e to the power minus 4t is equal 8 divided by 45 times 5 divided by 2t. So this is 9, this is 4. So therefore it is equal e 1 minus e to the power minus 4t is equal 4 over 9 t. So now this t is the time to take the time taken to land on the ground. Okay, now what we need, we have to solve 1 minus e to the power minus 4t is equal 4 over 9t, that equation. So that exponential and linear equation are here, but this is very difficult to solve. Therefore that graph is given here. It says that you have y is equal 4x equal 9, and the other one is y is equal 1 minus e to the power minus 4x. So that means these two graphs, the intersection point of these two graphs mean the solution of 1 minus e to the power minus 4x is equal 4 over 9x. So that x is the intersection point, the x coordinate of the intersection point. So in our one, it is 1 minus e to the power minus 4t is equal 4 over 9t, which is exactly the same as this equation. So therefore the solution of t is, therefore solution for t is equal 2.25 second. Okay, now if we know that time to land was 2.25, then the horizontal displacement is this t, we have to substitute into the displacement vector for x. So that is, we know that displacement vector is 5 square root of 3 1 minus e to the power minus 40. So this is equal, this is the range. Now range is 5 square root of 3 1 minus e to the power minus 4 times 2.25. So when I simplify that one, this is equal 5 square root of 3 1 minus e to the power minus 10. Now using the calculator we can solve, we can simplify that one. It is equal 8.6 pi 9.918 8.65 9.918, which is equal to 8.7 meters to the nearest meter. So therefore the range is 8.7 meters.